check this out. So before yesterday, on absolute value equations, our total score across this class, my other classes, the mastery on that learning target was just 63%. Ew, not good. One of our worst, really. Yesterday, on our exit ticket, I think we got like a 95% on this same learning target, and across classes, a 90%. So it's pretty cool, like even just one day, how much more we're able to master of this content. And we're going to do something very, very, very similar today, except for instead of talking about absolute value equations, we're going to talk about our next topic, which is systems of equations, like the questions you just looked at, which was our trickiest topic from Unit 2. And today's going to go very similar to yesterday. We're going to answer a lot of questions. We're going to take an exit ticket, we're going to discuss it, and then we're going to take a real exit ticket that's going to replace your lowest grade from that learning target. Similar to yesterday. Okay. Oh, one other thing. Remember yesterday I said that I need a videotape for a class I take on Tuesday nights? We're going to do that for a few minutes today. Amani is our camera person. Thanks, Amani. She's going to videotape me just for a few minutes, and then at the end of class, I'm going to videotape some of you discussing something for a few minutes. I hope that's okay. Come talk to me after class if it's a problem, but only 3 other people are going to see this, so I hope it's okay. All right, let's take a look. Let's learn these systems of equations so that when you get to the final, you're super ready to answer these questions. Like yesterday, I'm going to pull popsicle sticks, so pay attention, be ready to answer a question. We're going to go fast. We're going to crank through this. Flip over to page 2 of your notes, please. These are 3 different systems of equations. In each case, the equations here match the graph above. The equations here match the graph above, and same here as well. In your own words, how would you define a system of equations? Claudia? From what you see on the board, like what are some ideas you have? Okay, close. Who can build off what Claudia said? What do you think of when you think of a system of equations? Maria? How many equations are there in a system of equations? That's true. And both of those equations are graphed together. So if we have 2 equations and they're graphed together, what can we say a system of equations is? Who can help Maria out? A system of equations. Vern? Sometimes they do. What about here? This is also a system of equations. Any other volunteers to help us out with system of equations? Christina? That's the solution to a system of equations, and I'm glad you remember that. Thanks. I would say a system of equations is 2 lines graphed on the same graph. 2 lines graphed on the same graph. So Claudia, what is a system of equations? And Maria, what's a system of equations? Cool. So this is an example of that. How many solutions does this system of equations have, Christina? You're right, it does. And how did you know that? Perfect. moving over to the second system, these equations in this graph right here, how many solutions does this system have? Anthony? How did you know that?
Because the two lines never touch each other.
That's true. Is there a math vocab word you can think of that means two lines never touch each other?
Parallel.
You got it. And what do you notice looking at the slope? These are the two equations. These are the two equations that are graphed here. What is the slope of the first equation? What is the slope of the first equation, Jesus? It's in y equals mx plus b format. So do you remember what the slope is? Mel, to help him out. It is, or just that 2 right there, which is 2 over 1. So Jesus, the slope is? Yeah, and what is the slope of the second equation? The same. Interesting. There's no solutions, but we can say that the slopes are the... Yeah. So let's write that down. And what is the y-intercept of the first equation? The y-intercept of the first equation, Isaac?
1.
And the second equation?
-2.
So what can we say about the y-intercepts?
They're different.
I'm going to draw arrows to each of those. Moving to our third system of equations here, how many solutions does this system have? Joshua?
Infinity.
I'll say infinite, but yes. And it's a little tricky looking at this because we can actually take out a 2 out of the second equation. So let's make this, if we divide everything by 2, we could reduce this second equation to y equals 3x minus 2 by dividing by 2. Took out the GCF of 2. With this system, what is the slope of the first equation, Jenny? The slope? And what is the slope of the second equation, Jenny? It's not 3x, but it's, the x isn't part of the slope. The slope is the m part, so just So what do you notice about the two slopes? You got it. And what is the y-intercept of the first equation, Vanessa? And the y-intercept of the second equation? What about the reduced one? So what can we say about the y-intercepts? Interesting. Let's go back all the way to the left to the one solution system. What can you say about the slopes of this one solution system on the left? What can we say about the slopes, Wilbur? Are they the same? So they're different. And Wilbur, what can we say about the y-intercepts? So to summarize, just from looking at the equations, we can tell a lot about a system of equations. If a system of equations has the same slope, but a different y-intercept, the same slope but a different y-intercept, how many solutions must it have, Angelica? The same slope but a different y-intercept. True. And what if it has the same slope and the same y-intercept? And we'll call on someone else. Let's say there's a system of equations with different slopes and different y-intercepts. How many solutions does it have, Alondra? You got it. So actually this is a really cool way to quickly speed through some of these systems of equation problems. For example, number 1 down here. Looking at number 1 and referring back to your notes if you need to. How many solutions does number 1, this system here, have? Emily? You're right. And we could have done math. We could have solved this all out and found that there were two numbers that were not equal to each other. But even just by looking at this, that really sped up the process and really helped us figure out the system really quickly. Okay, I think you get the point. We're going to take an exit ticket pretty soon, our first practice exit ticket. But first, let's practice a little bit. So for the next 7 minutes, work silently on the practice problems. Refer back to those notes if you need to. But for the next 7 minutes, we are working silently on the practice problems.